We are back. 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 Welcome you back to Mwalimu Education Services. So we are trying to dissect this item. We are trying to dissect this item, and I think it was digested fully and concretely. I was able to go through it, and we interpreted it very well. We interpreted it very well. So don't forget our response structure. The item has been dissected very well in the previous video. So if you are watching this for the first time, I'll refer you to the previous video to kindly go through uh, the dissection of the item. So don't forget, this is our response structure. We start with the physical properties. Let me highlight them here so that I don't lose my point. So we start with the physical properties in blue. Physical properties in blue. Once the item has been interpreted, then we have to link as in we have to link each and every mentioned physical property. That is, if one can identify one, we link it to the scenario and explain it concretely in relation to what has been given. You have to synthesize. Now you see here in this case, you have to synthesize compound B and compound C. Compound P is prepared in the laboratory by heating hexanoic acid. So we have to prepare compound B, that is synthesis. Compound C is prepared by reacting one bromoethane with sodium metal in dry ether. So this is also synthesis. Because we don't know B and C, we must synthesize it. For A, we are a bit lucky. We are a bit slightly lucky. Why? For A, they have just told us that that compound A is what? Compound A is a straight chain hydrocarbon. That is what the item has stressed. It is just a straight chain hydrocarbon. It is straight chain hydrocarbon. So meaning that we simply know that it is a hydrocarbon. Yeah. So that is compound A. Compound A, straight chain hydrocarbon with 6 carbon atoms. So for it, we can jang around with the molecular mass that has been provided. Hope you've noted it very well, and we formulate it. But beyond C, we have to write synthetic pathways. Synthetic to show how B and C are prepared explicitly from the given raw materials. So those are the synthetic routes. They must be outlined. Then after the synthetic routes, one has to outline mechanisms for the reactions. One has to outline mechanisms for the reactions. Now here still one has to understand the scenario concretely, and the scenario at times may be somehow summarized in a way that it may not require a lot of uh, abstract interpretations. Like here, you see in our tasks, they have told us analyze the synthesis of compounds B and C. Analyze the synthesis of compounds B and C. You see, synthesis, you know they want synthesis of B and C. So that is direct. You have to synthesize B and C. Then explain the reactions of compound A, including the mechanisms. So you have to outline mechanisms for the reactions of compound A. Yeah. And currently, just as I have said for physical properties, currently they require you to explain 2 or 3 physical properties. Currently, you never know. You never keeps on updating this information. You never know at the end of the year, your teacher can tell you that 4 properties. Don't say, they told us this. No. This information is dynamic. It is not in equilibrium. So So it keeps on changing. This is two. That's why part B is saying analyze synthesis of compounds B and C. Those are two compounds. Mechanisms outline two mechanisms for the reactions. Then also lastly evaluate application. It is here. Let's evaluate. Uh, on my screen is visible. I think it is. Evaluate application of the compound or compounds. Evaluate danger of that compound, and explain mitigations to those dangers. Now the item has been explained or dissected concretely. So now we have to go through all this information. Your response, your standardized response, it has to capture these four things: physical properties, synthesis, mechanisms, application, danger, mitigation. The way they are here. The way they are here. Physical properties, synthesis, mechanism for the reaction, evaluate application, evaluate danger, evaluate mitigation. So physical properties, you can start with synthesis, and in this question, for simplicity, we are going to start with synthesis. So that, why do we start with synthesis? So that we can know compound B and C plus A. So that we know these compounds we are dealing with clearly. That's why we are starting with synthesis. It doesn't matter, you can start with anything. So what responses uh, colleagues, we are back. Some kind of challenge with this network. However, we continue. So I was saying that we start with the synthesis or exactly. So let us start with the easiest. Let us start with the easiest compound. That is about compound A. Compound A, a straight chain hydrocarbon. Straight chain hydrocarbon. So what does that mean? So if compound A is a straight chain